Hi, I am glad to see everyone live and I hope in safety. I look forward to a fruitful day. First presentation on the topic Immersive University Model, Widening and Testing Immersion Abilities. Authors Artyukhov and Volk from Sumy State University. Please.
Yeah, thank you. Just a minute, let me share my screen. Unfortunately, I can't share my screen. It says the organizer has disabled this ability. Can you do something with that?
Andrei? Help, please.
Hold on.
Help, please, Iurii Volk, for demo your presentation.
Yes, so when I try to share my screen, it says that this option is disabled by organizer.
Andrei, please undisable presentation for authors.
Seems it. Oh, okay. Just a minute.
Okay.
Can you see the presentation?
Yes.
Great, great. Okay, thanks for the opportunity. Greetings, first of all. My name is Iurii Volk, and I'm here to present a paper on Immersive University Model, Widening and Testing Immersion Abilities. We greet you from Sumy, northern outpost of Ukraine, and we hope this finds you well. So, an electronic university is no longer something new in educational practice. However, it requires the creation of ever new tools to attract students to effectively master the skills demanded by society and job market. Students enroll to university to study or self-educate in some cases, and the university actively uses models that allow students to successfully complete these tasks. Our work is bound to discuss immersive learning techniques and crystallize immersive university model. So we try to substantiate the effectiveness of immersive learning application for youth. Emphasis here is placed on the fact that immersion of students can be carried out not only through visual and augmented reality, but also in any constructed environment that provides any kind of immersion in active and interactive teaching methods. That's why we try to construct environments of any kind. We use the bibliometric analysis to figure out the interactions and relationships between the keywords, which I will show you in a minute. And based on that bibliometric analysis, the concept of forming an immersive learning model based on sequential transition between the dimensions, like on the multi-level classification, was formed. Basically, we implemented this multi-dimensional classification. We tried to allocate some tools for that and proposed it as a framework for building a immersive university case. And finally, we came to case study. We try to illustrate that the effectiveness of that classification with some certain practical tools that we already have in our hands, and we try to use them in the educational process. That's the technological solution proposed for evaluating the effectiveness of testing of such approach and immersive learning tools. With that being said, and getting back to bibliometric analysis, it actually, yeah, now it should be okay. Bibliometric analysis was conducted like as following steps. We have at the first stage, we select over 24,000 of articles using the word immersive in the Scopus database. Due to the lack of specification of immersive technologies application for particular field of knowledge, we are ought to introduce some restrictions. And regarding educational activities. Subsequently, we use the knowledge field social sciences. We select only first 1,000 articles by the number of citations for the period since 2010-2021, and eventually the keywords mentioned at least 10 times. This limitation to field of knowledge allows us to observe the growing interest in the use of immersive technologies. So we basically see by these clusters of interest which is in demand by the research society. The results made it clear to draw following conclusions. First of all, the immersive learning model requires expanding the list of tools. Usually we talk about the immersive university, immersive learning as only the augmented reality or virtual reality. However, it's not the case in real world. It's more than that. The model of immersive learning requires systematization in terms of tools description, because they are often just misplaced. A structural and logical model of an immersive university and some cases of its elements should be proposed. And finally, the model of an immersive university requires a unit for testing the effectiveness of the tools used. The formulated problems on this step correlate with general trends in the development of education and ensuring its quality in terms of achieving sustainable development goals, digitalization of education, knowledge management, and so on. So pretty much anything about education quality assurance systems in modern educational activities with the external assessment of the university educational system is also applicable here. So pretty much everything is are in line. Immersive university is a part of university in a gadget concept. So it's not like only the university in the gadget. However, an immersive university in the gadget is not a guide app. So we do not pose it as a guide app. It's more of a concept. It's a set of tools like augmented reality apps, 360 degrees instruments, various video apps, VR supplements, necessary gaming mobile apps, scenario creation tools, whatever. This diagram allows to understand that we have to have input channels that we can, with which we can certify the input of our students and of our staff, and the output channels which will allow the immersion per se. Another concept that allows to understand the immersive university as an information system, and I believe it gives the more of zoom out understanding of what's happening here, like a set of tools and scenarios. But it does not mean that the one need to use all the tools at once. So it does not mean like that. In this scheme, we present the component diagram of immersive university as an information system. We consider the immersive university as a high-level component. So yeah, if it allows me to do this, yeah, here. The immersive university as a high-level component. So it's my major component, which port is interfaced through educational demands and programs with students. So basically, students interact with the immersive university through the interface of educational demands and programs, which can be formulated by them or by the state, and then it's ported to the immersive university component. Low-level components inside the immersive university, such as VR instruments, conventional teaching techniques, on-site scenarios, augmented reality instruments, educational games, and collaborative simulations, are altogether interfaced through e-learning environment. So this does not mean that we have to use them all at once, and this will be the exact output to the students directly. It will actually mean that we have the ability to select the tools we need and to effectively interact with them through the set interface. Immersive university is not only the constructed worlds again. So we do not talk only about the constructed worlds and scenarios and put a stop to that. It's also the methods on basis of which these worlds are constructed. So again, zoom out a bit. That being said, students' involvement to assessment activity, students' involvement to preparation of scenarios, active and interactive learning scenarios, gamification, unusual forms of classes, creating a problem situation with a polylog mode. All of that contributes to the immersive worlds construction. Pretty much is separate, each of separate paradigms can be selected as the construction method for the immersive worlds, thus contributing to the general concept. And if we get back a few bit, this may help the interfacing for both of these components, major one and low level ones. Continuing on, we propose the classification of immersive education tools. Based already on what I have said before. So from 1D to ND immersion, let me walk it through you. 1D immersion is the verbal experience transfer, creation of scenarios or designs of the educational environment, including those engaging students. 2D immersion, that might be the existence scenarios for creating an immersive space in the virtual or real world. 3D immersion is mostly that's the thing that we often discuss in terms of immersion, right? Three-dimensional training models. That's the most popular case of discussion in case of immersion. 4D, that's the next most popular, AR plus, augmented reality plus, on-site role-playing games. And often these two components are considered only components of immersion. However, no, 2D and 1D immersion is also important, especially even reading text is an immersive tool. It's the question of approach, actually. 5D immersion is the full-scale VR, where all the tools are incorporated. And we propose to consider ND immersion pretty much, you can put any figure here, like 60, 70, whatever, that can be gamification in the virtual world, created and dynamically changing directly during the game. So then the dynamics of these scenarios that are developing, that are developing directly during the interaction and during the immersion of the person there is the case. Here are some examples of immersive learning tools. For example, here you can see a series of posters on academic integrity with elements of augmented reality. We can talk about this as a 2D plus 4D concept. We have the 2D image, which has the pictures and text on it, and it can immerse the viewer to the augmented reality. So when you put on your phone on that QR code, it will allow you to hear out the sound and to see a video of a character who will explain what's happening in the poster and what's this about. So that's pretty much the case of 2D immersion, existing scenarios, plus 4D AR plus. Next case, 1D plus ND. That's the example of gamification. The method of educational activities gamification is widely used at all levels of educations, and this is the type when we have the scenario, preset user scenario in gamified world. Pretty much we can change the scenario dynamically, like in Minecraft world creation, and this is an example that we try to incorporate in our course, where we have a meeting of participants. We act in the game, we interact in the game on the pre-existing scenario, but it may and will change throughout the game due to the interaction of all the people between themselves and due to the interaction with the world itself. Now this leads us, everything being said, leads us to the idea how to choose an appropriate immersion instrument with certain dimensionality.
Ну, почти да. Я слушаю, ничего не понимаю, понимаешь?
Андрей, off microphone, please, Marchuk.
Yeah, that leads me to the point where we have to choose the appropriate immersion instrument with certain dimensionality. And that might pose a challenge. How to choose the appropriate dimensionality? ND, 1D, 2D, 3D, which one? One has to possess a methodology and equipment to evaluate the effectiveness of immersion tool and assess expediency of particular immersion tool implementation. One of the possible solutions is behavioral studies. Okay, with engaging proper equipment and proper number of participants. Like if we create a stable participants pool who already has the experience with previous n-d research n-d dimensionality, that might come in handy. We propose to use the iMotion software with eye tracker and GSR sensor. That combination allows to conduct full-scale behavioral studies, and it allows evaluate immersion instrument effectiveness. You can actually detect what emotions human is experiencing right now. So excitement, anger, joy, sadness, whatever. So you can actually see it on graphs, how the person immersed in this scenario experienced that. And you can see the fixations of the eye on the screen with areas of interest, which was the perfect case here. Of course, heartbeat and galvanic skin response will also contribute to the analyzing of emotions and excitement and immersion, the stage of immersion of the person inside of this scenario. As the deliverables, we can have like the AOI map for each stimulus, aggregated data, and so on. So if that arises some questions, I will be glad to answer. And finally, we come to conclusions. Within the framework of the current paper, we proposed a new perspective on immersive learning concept formulation, which stands different from considered literature. Immersive learning is not limited to the worlds of virtual, augmented, and mixed reality. Pretty much any active or interactive action with the participation of students is an immersion in the world with its scenario given or created in the learning process. Thus, pretty much, this paper is about creating a complete cycle for each component of immersive learning development, trial access, testing, improvement, implementation stage. The highlight of proposed model is the ability to test immersive learning tools not only based on user feedback, but also based on their behavior study. And that's the major outcome here. So we actually propose the algorithm to use the behavioral studies to analyze the immersion effectiveness. On this, thank you very much for your attention. I will be glad to answer any questions that may have come to you for now. In case when you need to find us, feel free to reach out through the contacts listed on the screen. Thank you.
Thank you. A very interesting study, especially to play when many universities will go virtual and use augmented reality for their work. Questions, please.
May I give a question?
Sure. Please go ahead.
I want to say that your idea is very interesting and new for me. And my question is not about technical details, but about teaching maybe elements. So I'm sure that students were interested in your course about academic integrity with this augmented reality. But could you tell, have they fully realized these integrity principles and used these principles in their next practice?
Okay, no, we are actually, it's hard to say whether they realize it fully, okay? Because we have no proper instruments apart from user feedback. User feedback is a biased thing that can actually be, mixed up with their minds. However, as we able to analyze it, since they have the course of academic integrity on the master level and they possess the same selective course on the PhD level, they can go from master level to PhD and select another course in research integrity. And when they come to the research integrity with a background on academic integrity, they actually possess a fine amount of knowledge that we can see actually, and then they apply that. Apart from that, talking about incorporating the academic integrity principles in their everyday lives by analyzing their qualification work, for example, and their feedback on academic integrity declarations that we have in our university, yeah, they know the principles and they use them. And of course, if they try to use some misconduct throughout the course, they are facing some real consequences, of course.
Thank you.
Yeah. I hope that, yeah.
Next questions.
I believe somebody in the chat.
Okay. I have a question. Maybe this the same question, maybe not. But how in your learning model implemented feedback? So how your system adapt for the students' progress and how selecting next activity for learning based on the current student activity and current student progress?
So can you, I believe that you can still see my presentation, right? Okay, so talking about, excuse me. Yeah. So yeah, immersive world construction methods incorporates polylog mode and students' involvement to the preparation of scenarios. That's how we can use their feedback, their actual feedback, to adapt the scenario for further learning. Apart from that, if we talk about formal things like how to change the course and the approach to teaching, exactly, we have the system for substantial feedback about all the course materials, not only the immersive builds, but how the teacher was behaving, how often he was late for the classes, so on. All of this feedback can be incorporated by the teacher on the further step when he adapts the course on the next year or on the next group. And in this particular case, if we talk about, again, we downgrade to the immersion, students' involvement into preparation of scenarios will actually contribute to changing that scenario according to their preferences. Of course, their preferences might not be the same on the previous course and on the next course, but nevertheless, it helps to adapt to the need of audience. I hope that answers your question.
Does your system make it automatically or need some manual impact from the teacher?
No, of course, it needs manual impact and greatly. It's not like an automatical. It's not like, do not, let me pose it that way. Here is not an automatical system. It's just a system of approach. It can be gamification, as I was showing, like Minecraft. It can be posters, and which of that tools are going into the course, it's the decision of teacher and this decision of the like executive staff, whatever. So it's, of course, it requires manual impact. And so, for example, the creation of Minecraft world is fully manual so far, of course, apart from generating landscapes. But nevertheless, it takes some time.
Thank you very much.
Thank you. Thank you.
Thank you.
Okay. Thank you. Next report, the phenomenon of clip thinking in the educational and cognitive activities of students of natural and physical mathematical educational profile. Authors Shestopalova and Goncharova from Kryvyi State Pedagogical University. Speaker Tatiana Goncharova. Andrei, please turn on the video presentation.
Good afternoon, everyone. Allow me to introduce myself. My name is Tatiana. I'm a PhD student of the Department of Practical Psychology of Kryvyi State Pedagogical University. The topic of our speech is the phenomenon of clip thinking in the educational and cognitive activities of students of nature and physical mathematical educational profile. Since we have very limited time today, only 10 minutes to presentation our research, we are going to be brief. You can read more about its results in our publication. If you have any question, please hold them until the end of our speech. We will be glad to answer them. Let's make a start. Our work consists of two main steps. The first step was a theoretical analysis of the peculiarities of the process of cognition in modern years, in which the cognitive process of perception and awareness of information are significant changes that affect the quality of professional knowledge. More science Francis explains this by the transformation that occur in the informational space and the peculiarities of informational perception, which in turn provocates the emergence of the phenomenon of clip thinking. It doesn't allow students to create a holistic view of certain events, facts, provokes an emotional attitude towards them rather than logical, forms superficial knowledge. Therefore, we tried to find out at which level of cognition clip thinking is activated and how in general it can affect intellectual activity. Now I want to draw your attention to the table which you can see on the slide. It presents the result of this theoretical analysis. As we can see from table, clip thinking is similar to rational, which dominates the empirical level of knowledge in such criteria as interaction with the object of knowledge, especially the analysis of information. The result is either superficial knowledge or the establishment of an empirical relationship between individual phenomena. According to other criteria, no similarities were found between them. It's noticeable that according to the essential characteristics, the opposite of clip thinking is theoretical thinking, which is capable of comprehending meanings, creating a holistic picture of the world. Thus, summarizing the results of comparative analysis, we can assume that in the general phenomenology of cognition, the mechanism of clip thinking provides the first stage of cognition, which presents individual empirical facts which contain the author's opinion, which may not be an expert in the field, presents the material. That is, the obtained data is only a material in which the subject is present with the subject contact and which, in the process of perception and comprehensive, undergoes various ways of cognitive transformation. In addition, we theoretically analyzed the hypertext format for providing information, namely which combines the visual presentation of information with the audio. This format is quite common not only in the educational process but also in the daily lives of students, and some scholars point out that the emergence of this format led to the emergence of clip thinking. Therefore, it's important to know its features and how it can affect the quality of information assimilation. Such extensive work was carried out in the first stage of our research. The second step was to empirical verification of our assumption about the transition to a new cognitive style that has the properties of clip thinking. The main purpose of our experiment was to identify the peculiarities of information perception and further cognitive processing of information present in the linear format and using visualization tools, namely hypertext. The tool sample was 68 students of physics, mathematics, and natural science. In the text of our publication, you can find a more extensive explanation of why such students was chosen for our research. The experiment was conducted as follows. The subject received information as a lecture in the two formats mentioned above with an interval of 2 weeks. That is, group was proportionally divided into two subgroups. First, one subgroup worked with linear format of information presentation and the other with the use of visualization tools. 2 weeks later, the subgroups changed places. To check the quality of perception and residual memorizing, a Google form was compiled with questions to the content of the lecture, which needed to be answered openly. Let's move on to our next slide, in which you can see a generalized comparison table of the results. We intentionally don't show you quantitatively indicators in the forms of diagrams for each question because unfortunately our time is limited and for us it's more important to summarize these results. But if someone wants to learn more about them, you can do so in our publication. So back to our table. To determine the effectiveness of a format, we have selected the following criteria that you can see on the slide. We see that understanding of the purpose of the information provided good in two format demonstrates the connection between theory and practice, usually with the use of visualization, and this does not require further explanation. The division of information by students into separate semantic parts and remember information that is not larger in volume as we see is also better in the second format. This can be explained by the fact that during visualization, such as lecture, we switch the slide and we all understand that now they will say something new. We need on focus, and it's in a traditional lecture to understand that there has been a change of mind. You need to be focused all the time, and if the lecture does not use logical pauses, intonation, it will be even more difficult. And memorizing large amounts of information, completeness of answer and depth of residual knowledge are an advantage of a linear format. We established this on the basis of questions that needed to be answered openly with our own consideration. The students' answers were more extensive. They used full sentence using different parts of speech. And in another format, these answers were more concise. Sometimes one sentence at all. It was really difficult to explain why this happened because for better memorization, there was a visual format for providing information, but students could not put it into a quality text. Also, it is worth noting that there are no significant difference between students of different faculties. Finally, let's sum up our speech. As a theoretical stage of our work, we suggested that the mechanism of clip thinking work at the intentional empirical level of cognition, but a possible reason for this may be emergence of such a format for providing information as hypertext. At the empirical stage, the traditional and modern format of informational presentation has its advantages and disadvantages. Students are not able to fully master the material provided in the classroom in any of these formats. Therefore, further works is a deeper empirical study which aims to identify mechanisms that inhibit the intellectual process of modern years. Thank you for your attention. If you have any questions, feel free to ask them now.
Thank you. Questions, please. Okay, my questions. Say, please, how clip thinking improves the effectiveness of student learning?
Sorry, please repeat. I don't heard. Technique is bad.
Okay, repeat. Yes?
Yes,
okay.
yes, please.
How clip thinking improves the effectiveness of student learning?
Thank you for your question. Clip thinking is now is more popular in our students because they learn social information such approach, and this format cannot do them.
Technical problems. Okay. Thank you. Thank you. Technical problems. Very difficult questions. Thank you. And next report, blended English for specific purposes course with a focus on critical thinking skills development for computer science students. after Zaitseva Simonenko from Dmitro Mutorny in Victoria State Technical University, and Vyacheslava Sachi from Bogdan Khmelnytsky Melitopol State Pedagogical University. Speaker Vyacheslava Sachi, please turn on the video presentation. Thank you.
Dear participants of International Conference, we are glad to present the results of the joint research of two Ukrainian universities, a blended English for specific purposes course with the focus on critical thinking skills development for computer science students by Natalia Zaitseva, Svetlana Simonenko, and Vyacheslava Sachi. Efficient forms, methods, and approaches of the professional training of specialists in different fields have been the research aims of researchers and practitioners for decades. Nowadays, the COVID-19 pandemic outbreak, the military actions of the territory of Ukraine have drastically changed the attitude towards the education, training goals, means, tools, and relationships of teachers and studies have been reconsidered. The attention focus has shifted from the final result to the emerging challenges of the education process due to the switch from conventional schooling to online learning on blended learning. So, the main points of our report today are blended learning in foreign language teaching, blended learning in teaching English for specific purposes to computer science students, and changing student critical thinking skills in the ESP course. The crucial importance of learning foreign languages for computer science students has been recognized by all the participants of the educational process, by education administrators, potential employers, stakeholders, etc. Its signification for Ukrainian students has been formalized in a number of normative national guidelines, a regulation which can be seen in this slide. As students majoring in computer sciences have been proven to be open to advances, blended learning implementation has not seemed to be a high issue recently. There are numerous definitions of blended learning of researchers in the fields of pedagogy, psychology, etc. This slide lists some of the definitions. Numerous slides on blended learning have been carried out by researchers in foreign language teaching. Most researchers agree on effectiveness and application for blended learning in teaching and language foreign languages. At Dmitro Mutorny State Technological University, students are given the opportunity to apply for a dual learning program or for an individual study plan, and they get a job by their future trade. In order to provide both the attendees of conventional classes and employed undergraduates with all the necessary knowledge, skills, and competencies, with the discipline course blended, mod Skylab, and the blended English for specific purposes courses have been developed. Within the course, there are three main goals to be achieved: improvement of the level of command of English, inclusion in computer science, undergraduate professional skills for successful collaboration and immersion into working environment, and developing the 21st century skills. The peculiarities of the course are the following: in order to allocate time of the study, lower effectivity, learning strategically in these aspects like complex memory and vocabulary ones, and authoritative text processing techniques and include in the traditional learning mode. Time-consuming tasks like studying authoritative text, audio and video materials in English, as well as collaboration, invitation, problem-solving, critical thinking, etc. tasks are placed within the self-studies mode of the ESP course. The methodology of the plan employs the learner-centered approach, the task-based approach, and the communicative method. The intellectual partners include individual, peer, mini-group, and team work, face-to-face communication between teachers and students, as well as peer reviewing. Teachers are expected to provide facilitation that instructors' science professional skills will help undergraduate certification, acquire new vocabulary, and that goes to major part of the text task. The blended learning for specific purpose course has been scrutinized in order to estimate its effectiveness in comparison with the traditional ESP courses. The evaluation system included an informal conversion, regular student questionnaire, and a post-course survey. The ESP teaches reflection on the course employment challenges and advantages. Based on the evaluation results, the introduction blended ESP course has been redesigned according to the new study load and upgraded with the new statistical study modules according to the student feedback. The blended English for specifically proposed course with a focus on critical thinking skills development has been created. With this course, different skills are accessibility and changing, identification and recall of the information on the specific theme, selection of facts and titles, analysis and synthesis, evaluation through development, and presented our ideas and opinions. The formatting and changing the students' critical thinking skills in the present ESP course in the spring team 2021 was based on the three-stage system of Agile Steel, Merrills, and Temple. The strategy includes evocation, realization of a meaning, and reflection. This slide lists in-class activities, online activities, and the teacher's role while studying one of them. In-class activities include reading for detail, practicing reading skills, speaking and writing activities, grammar revision, watching videos, carrying out the pre- and post-watching activities, giving and evaluating the presentation, argumentative speaking. Online activities include listening, improving grammar skills, teaching for information, composing and designing a presentation, writing an essay with a focus on the video content critical analysis. Practical examples of in-class and online activities are presented in this slide. All the details can be found in our paper. In conclusion, we should emphasize that the 21st century skills should be formed and improvement in the prospective IT specialists. Within the blended English for specific purpose course, the course participants are trained in carrying out the efficient information analysis and IT product evaluation. The presented learning strategies support students on their critical thinking, evolving from their ability to interpret, to appraise, to prioritize, and to evaluate the information, the ability to decide, to conclude, to compose, and to originate, as well as to present new ideas in English in this gradually format and unchanged. The main references of our paper are given here. Thank you for attention.
Thank you. What questions will be?
I have a question.
Thank you.
Could you tell what learning strategies will allow students to develop their critical thinking while studying this course?
Thank you. Within the blended English for specific purposes courses, where the teachers and are the facilitators, the most professionally oriented settings information is provided by the students themselves. The course participants are trained in carrying out the efficient information analysis and IT product evaluation. The students' ultimate task is to give their opinion about the maintained about existing products and to voice their utilization suggestion. Such learning strategies support students on their critical thinking, evolving from their ability to interpret, to appraise, to prioritize, and to evaluate the information. The ability to decide, to conclude, to compose, and to original, as well as to present new ideas in English, is gradually formed and enhanced. Thank you for your questions. Thank you. Next presentation, personal e-learning environment of the math teachers.
Excuse me, Natalia, hand up, or I'm sorry.
Yeah, if I might ask a question, I would be grateful because this is the second time I'm trying. So, well, I'm interested in your professional opinion. My question is about ESP. We have been thinking about whether it is worth to teach students ESP or still general English, because if we are talking about international certificate exams or like TOEFL or IELTS, it is not like ESP purely, it is mostly general English. So what is your opinion? Is it absolutely necessary for the IT students to know, to be taught like ESP, but not general English? Thank you.
Thank you for your questions. For IT students, will be English learning because for IT industries, English forever general English, and no IELTS, no TOEFL, and excuse me. And general English for IT students forever.
Thank you very much. I understand you because, you know, according to my experience, any interviews for taking IT employees to work is based, they are actually based on general English. And well, creative thinking or critical thinking is, to my mind, to my personal opinion, is easier to be taught like on general topics, but not only like specific topics in the IT sphere. Thank you very much.
Thank you. Thank you. No questions. Because next presentation, personal e-learning environment of the math teachers online courses as a means of improving information communication technology competence of a mathematics teacher. Authors Vlasenko from National University of Kyiv Mohyla Academy, Chumak from Donbas National Academy of Civil Engineering and Architecture, Lovyanov from Kryvyi State Pedagogical University, Khan from Brouadcast State Pedagogical University, and Sitak from the Vladimir East Ukrainian National University. Speaker Olena Chumak. Andrei, start please.
ICT competency
Thank you.
as a mathematics teacher. In the current circumstances of the global spread of distance learning, the problem of teachers' awareness of various information and communication tools is increasingly growing in importance. Their use by a present-day teacher is closely related to the selection of web tools for creating their own personal learning environments, PLE, which provides a variety of activities. All this entails the need to constantly train teachers and form their ICT competency. Several studies have been devoted to addressing certain issues of the problem of maths teachers' ICT competency. Thus, the United Nations Educational, Scientific and Cultural Organization, UNESCO, in partnership with leading industry organizations and experts from different countries, developed ICT competency framework for teachers' recommendations. They include 18 competencies that are structured in accordance with 6 aspects of professional teaching activities and 3 levels of applying ICT for teaching purposes. The underlying idea of developing the above-mentioned competencies is that teachers who possess a sufficient level of competencies to use ICT in their professional activities will be able to ensure high quality of education. In this regard, both foreign and Ukrainian researchers mostly consider the issues of forming ICT competency of future teachers in the process their training. However, the continuous improvement of web technologies necessitates the formation of ICT competency not only of future teachers but also the continuous professional development of those teachers who already work in schools and higher education institutions. Consequently, the need for the continuous formation of ICT competency of a teacher, including the one of a maths teacher, is beyond dispute. One of the best ways to address this issue, according to the researchers, are online courses that will help teachers navigate the space of web technologies and level up their ICT competency. That is the reason why there have recently been appearing more and more courses that offer teachers to improve their skills in the field of information technologies. Therefore, the idea of developing an online course for teachers to raise their awareness in the field of web tools is relevant. But, instead stated by the authors of the Eduge platform. Having a good idea is not enough for an online course to be a success. The whole host of factors that will interest the audience and encourage them to take the course should be considered. The most well-known traditional models for developing online courses are ADDIE, analysis, design, development, implementation. And evaluation is best considered as a classic representation of instructional design principles, its acronym associated with the 5 key principles of course design: analysis, design, development, implementation, and evaluation. DIG, Carey and Carey model is a systematic model of instructional design, first introduced in 1978. It is sequential in nature, similar to the ADDIE model. The model assumes the learner is active in the learning process, integrates the learner needs, skills and learning context into the design. It is a well-researched model that relies heavily on theoretical principles of learning, which no doubt is why it is a respected and widely implemented model in higher education. Instructional design model for online learning, IDLE, draws from the ADDIE principles and the DIG, Carey and Carey model. It's perhaps best described as a framework, since the authors of IDLE suggest it be used in conjunction with another design model, not as a replacement for. As a basis for the development of the course, we took a 5-step ADDIE model strategy. This model of a systematic approach is best suited for the students' active participation in the learning process. Over time, the content of each step, analysis, design, development, implementation and evaluation, may change. Thus, in the future, not only the teacher but also the student will be the target audience. This will not only affect the first analysis step but also change the further steps. During the search phase of the study, maths teachers were asked to independently select resources to fill their own PLE according to their activities, such as organizing the teaching process, searching for information, doing research, analysis and statistical processing of the information, doing the calculations, publishing popular science materials, publishing research papers, designing presentations, collaborating, communicating.
That's all?
No, I'm sorry, it's my problem. One moment, please.
Saving data. Based on this, we developed a PLE model for a maths teacher. This model at the present-day stage of the development of Web 2.0 technologies involves placing a maths teacher in the center, which results in the teacher becoming the starting point for creating an external network of nodes. Web 2.0 tools are designed to help teachers improve their skills and level up ICT competency. In Table 1, we analyze the various tools in terms of their functionality for the teacher. The presented personal e-learning environment of the maths teacher course is designed to prepare the teacher for these changes. This online course is designed for 5 weeks to be worked through at the pace selected by a teacher. If desired, the user can pass the course faster, but the optimum pace is considered to be the one that provides for 2 lessons per week. Each lesson is packaged with a short text lecture, a video, a tutorial and a practice assignment. Gradually working out the class tasks, the teacher masters various Web 2.0 tools. Ranking of Web 2.0 services and their distribution in accordance with the types of teacher activities provides for the development of useful PLE, improves the level of web tools mastery, helps to increase teachers' ICT competency. The experiment involved master's students majoring in mathematics in Donbass State Engineering Academy, Kryvyi State Pedagogical University, Berdyansk State Pedagogical University, a total of 50 volunteers. At the beginning of the experiment, the participants were randomly split into control, CG, and experimental, EG, groups. In the control group, 26 students studied the methods of teaching mathematics in a specialized school, MTMSSH, discipline following the traditional university program. In the experimental group, 24 students when studying MNMSH took the personal e-learning environment of the maths teacher online course. The indicators for the effectiveness assessment of the developed course were the levels of the ICT competency formation. Through the analysis of the scientific literature, 4 levels of the ICT competency were differentiated: very low, elementary, normative, high. Next slide. To determine the higher education seekers' awareness about the use of various Web 2.0 tools, we applied special testing. The analysis of the entrance level of the students' ICT competency showed no significant difference between the levels of its formation in EG and CG students. At the end of the experiment, CG and EG students did the test again. The results of the final assessment of the experimental and control groups are presented in the slide. As can be seen, at the end of the experiment, in EG we observed the redistribution of the percentage of students towards the normative and high levels. The overall increase was 19.9% compared to 4.3% in CG. Thus, at the end of the experiment, there was an increase in the normative level of the ICT competency formation in EG by almost 16.8%, while with the CG students this level increased only by 3.3%. The number of course users having a high level of ICT competency in EG increased by 2.6%, whereas in CG, only by 1%. The analysis of the pedagogical literature suggests that the development of online courses in the learning process is at the height of its popularity. The use of online courses is an effective means of increasing the ICT competency of both teachers and seekers of higher pedagogical education. The analysis of the results of the questionnaire survey among Hey Maths teachers confirmed their insufficient level of ICT competency and the willingness to increase it with the help of our personal e-learning environment of the Maths teacher online course. We are grateful to the students who took part in the experiment, the teachers who participated in our questionnaire survey and thus helped us in conducting the research.
Thank you. Questions, please? No questions? Okay. Please tell me how important information communication technology is competency for mathematics teaching, please.
I'm sorry. I believe that it would be better if I respond to your question because all our teachers, all my colleagues, we are out of house hour, and so we have some difficulties with presentation our reports. First of all, take my greeting with this conference, and I'm grateful for organizer for this opportunity to attend this conference. And of course, to answer your question, I will answer you the next, that first of all, this course, the aim of this course is collaboration between teachers who have some experience in usage of these competence skills, and of course some master students. And of course, nowadays we understand these skills and these competencies very important for master students for today must use their skills to give knowledge and to give information for their pupils, students, and of course our course give this information for them, and our teachers share their experience with students. Of course, when they give this information, they find they themselves learn how to use this information, how to develop their skills, and so this information is very important, and from this experience, master students understand how important is this.
Thank you. Very, very important information communication skills for teachers forever. Not for mathematical teachers only. Yes. Very good. Thank you. Questions, please. Okay, no questions. That's next topic, next presentation. Mathematical competence and mathematical abilities, structural relations and development methodology. Автors Semenets from Zhytomyr Polytechnic State University, Semenets Zhytomyr Ivano-Frankovsk State University, Andreychuk Zhytomyr Polytechnic State University, and Litsuk Zhytomyr Ivano-Frankovsk State University. Speakers Sergei Semenets. Andrei, on video presentation, please.
First of all, I would like to sincerely thank the organizers of the conference for the opportunity, honor and pleasure to participate in such an important scientific forum. I am sending my congratulations to the participants of the ICon-MaSTEd conference. And I sincerely wish you life in peace, future mathematical and educational mathematical victories. The present work is the results of our rather long scientific research, both in terms of theory, conceptual approach, and practice, methodological and experimental approach. The content structure of the work presentation is offered to your attention. Our pilot study was aimed at clarification of the state of solving the problem in school education. Questions were prepared for mathematical teachers where they react to answer questions about content, features, components of mathematical abilities, features of the methodology of mathematical abilities development, personal quality of teachers and students that ensure the development of mathematical abilities, the presence of students' mathematical abilities, the role of mathematical abilities and personal qualities of students in teaching mathematics. Its results are present in our work. Here we only note that according to mathematical teachers, there is still a lack of scientifically sound method of developing mathematical abilities of students. According to the results obtained and the competency model of education adopted at the state level, The purpose of the study is to establish the role and place of mathematical abilities in the dual nature of mathematical competence, to make semantic and systematic analysis of the structural components, to highlight the methodology of development of this personal formation, to experimentally test its effectiveness. Therefore, the author's definition of mathematical competence is presented in their paper. The doctrine of the dual nature of mathematical competence has been developed. The conceptual position on the duality of its manifestation was embodied in Cartesian realization. The composition of the external manifestation of such competence on the basis of three dimensions: X, semantic theoretical, Y, procedural active, and Z, referential communicative. The three-dimension structure of internal manifestation is represented by dimensions: X, value motivations, Y, reflexive evaluative, Z, personal psychological. In the present study, mathematical abilities are an immense characteristic, an essential feature of mathematical competence. The single that most represents its personal and psychological dimension. In this paper, we establish correlation between the structural components of mathematical abilities and the measurements of the external manifestation of mathematical competence. In this regard, the task of the present work include an experimental test of the development of mathematical abilities of first-year students and graduate students of the specialty 0-1 for secondary education, future teachers of mathematics. The following types of tasks have been developed: to develop a structural mathematical model of the content line topics, to build a mathematical model of an applied problem situation, to solve a mathematical problem by one of the known methods, to form a generalized way of action in the process of solving typical problems, to match formulas, equations, and their geometric interpretations, to solve a problem of the Olympic type, formulate heuristic prescription and roll down guideline for solving it, to compose new open task. The lambda criterion was tested for homogeneity, and it was found that the empirical distribution of mathematical abilities of freshmen and graduates do not differ. The results of the experimental confirmed the need to develop innovative methods of mathematical education. In the course of its development, 6 theoretical and methodological concepts present in our work were introduced. Innovative method of teaching mathematical implements a fundamentally different didactic model of mathematics education, which emphasizes tasks that enable a situation of success, task problems that activate mental activity, the independent formulas of goals tasks, the collective study of a mathematical problem, establishing the method of solving the problem, the formation of the generalized way of solving typical problems, the formulation of semantic theoretical generalization, definition, theorems, algorithmic and heuristic prescriptions, the performance of the reflection action in the teaching of mathematics. According to this model, a development problem method of teaching mathematics has been developed and present in the work. According to the results of a qualitative analysis of the experimental results, the following conclusions were made. First, science of systematic mathematical knowledge, competent of structural mathematics think, and a rival in EG. 2. EG students are better at the method of mathematical modeling. 3. The EG of graduate students better distinguish between typical problem situations, makes generalized method of action algorithms in the process of solving them. 4. Memory for topical mathematical relations, formulas, general resonance algorithms, content and structure of methods and ways of solving problem are more developed in NG students. 5. The problems of mathematical competitions are better solved by NG students based on the results of their solution, heuristic instructions, formulate and guidelines drawn up for using typical problem situations. 6. The most talented students have a specific cognitive style. Their mathematical activity is characterized by semantic generalizations and has a science of heuristics. The lambda criterion was used to statistically test the effectiveness of created methodology of mathematical education. The need for further scientific discourse, the acute social demand for competency-oriented and developmental method of mathematical education determines the prospect of our research. Thank you for your attention.
Thank you. Any questions, please? No questions. No questions. Okay, questions, please write in text chat, and we go to next presentation. And next presentation, the impact of psychological learning training on educational motives and reflective skills of future IT specialists. Authors Kryvyi, Artyukhov, Chorny, and Serduk from Bogdan Khmelnytsky Metropolitan State Pedagogical University. Speaker Irina Kryvyi. Start, please. Video presentation. Thank you.
Dear colleagues, I'd like to present results of the experimental research aimed to examine the impact of psychological and learning training on educational motives and reflective skills of future IT specialists. This research was conducted by the team of lecturers from Bogdan Khmelnytsky Melitopol State Pedagogical University. The main questions of my presentation are: what is motivation, what is reflection, research essence and results. I'd like to start by the role of universities in modern world. In this short speech, I note a few key points. Nowadays, universities are the centers of high-quality fundamental education, which is based on the principles of competence and student-oriented approaches. Universities are designed to meet the needs of other stakeholders, including the labor market and academia. One of such urgent requests is the need to implement educational programs of a shortened cycle for IT specialist training. Our research led to identify some contradictions that hinder the efficient professional training of future IT specialists. In particular, between the requirements for the professional level of IT graduates and insufficient motivation of higher education students to study and improve their skills. Between the educational needs of students and the limited ability to build individual education trajectories with a combination of different forms of education at universities. Between the availability of students with professional competences formed during the previous level of education and the IT bachelor's curricular content at universities. To overcome these contradictions, we developed teaching technique. This technique contains means for development of motivational, cognitive, operational, communicative, and reflective individual spheres. In this report, I focus on forming of students' motivation and reflective skills by the means of psychological and learning training. I'd like to discuss the main concepts of our research, motivation and reflection. First of all, to be motivated means to be moved to do something. There are two main types of motivation, extrinsic and intrinsic. Intrinsic motivation refers to doing something because it is inherently interesting or enjoyable. And extrinsic motivation refers to doing something because it leads to a separable outcome. Here you can see self-determination theory's taxonomy of motivation. According to this theory, intrinsic motivation is connected with person's autonomy and concerns a sense of initiative and ownership in one's action. Turning to reflection, I will note that there are different approaches to its definition. For example, Marshall states that reflection is a careful examination and bringing together of ideas to create new insights through ongoing cycles of expression and re-evaluation. According to other approach, there are three different meanings of the reflexivity concept. The first regards reflexivity as an individual's considered response to an immediate context and making choices for further direction. The second defines reflexivity as an individual's self-critical approach that questions how knowledge is generated. The third is concerned with the part of emotion plays in work practice. In this study, we focus on the formation and development of students' intrinsic motivation. We consider its aspects: motivation to continue education and training, motivation for professional activity as a software engineer. We consider reflective skills of future IT specialists as an ability to self-understand, analyze, and evaluate yourself as an individual, a specialist, a member of software developers team, as well as your own actions in the current situation, past and future. Our technique involves such elements: motivational training, training exercises, learning training. Some examples of these means are given on this slide. I'd like now to discuss the experimental design. The impact of psychological and learning training on motivation and reflective skills of future IT specialists was examined within the framework of pedagogical experiment. It was conducted during 2016-2019 at Ukrainian universities, in particular Bogdan Khmelnytsky Melitopol State Pedagogical University. The number of control group was 207 persons. The number of experimental group was 198 persons. Experiment included two stages. At the ascertaining stage, the initial level of motivation and reflective skills was examined. At the formative stage, developed technique was implemented in the experimental group. The empirical data were processed with Kolmogorov-Smirnov test and Fisher test. We considered that each of individual characteristics had 5 levels of forming, namely low, critical, medium, sufficient, and high levels. We used special psychological techniques to estimate students' individual characteristics. Let's consider the results of formative stage in more detail. You can see that the percentage of students with a sufficient and high level of motivation in experimental group exceeds the same percentage in control group. Here, you can see that the percentage of students with a sufficient and high level of reflective skills in experiment group exceeds the same percentage in control group. Here, the results of processing of empirical data as formative stage of the experiment are given. Statistical tests shown that there are significant difference between control and experimental groups. I'd like now to recap. Nowadays, psychological and learning training are widely used in formal and informal education to improve of learners' hard and soft skills. We develop pedagogical technique which involves motivational training, training exercises, and learning training, and then examined its efficiency for IT education. At the end of formative stage of the experiment, a positive trend in the formation of students' motivation and reflective skills was recorded in the experiment group due to implementation of the developed educational technique. So we can state that its implementation is effective and has a positive impact on the improving of motivational and reflective spheres of the personality of future IT specialists. Further research is aimed at developing and testing personalized training programs for use in the educational process of universities. Thank you for attention.
Thank you. Questions, please? No questions. My questions. I have a questions. Could you briefly describe your NoSQL databases training? Irina?
Sorry. Thank you for your question. The key problem of our training was the use of document-oriented databases. Because this question is not learned in main course of databases. Training is aimed at raising student professional awareness, educational motivation, and their reflective skills. Training tasks was to show students pros and cons of these document-oriented databases, especially database MongoDB, and to form students' skills to create such databases. The duration of this training was about 5 hours, because such training cannot have a short term. It consists of 3 parts: intro, main, and final, like all trainings of such kind. And to do students' experience more memorable, we use mini lectures, workshops, training exercises, and games. In my article, I give the scheme of this training and its structure. That's all.
Thank you. I have any more questions? No, that's all. Thank you. Next presentation. Computer addiction as a new way of personal self-realization of student use. Authors Yakovitska, Pomytkina from National Aviation University, Sinishina from Uzhhorod National University, Ishanskaya, and Gordienko from National Aviation University. Speaker Katerina Gordienko. Andrei, please play presentation.
Conference and listeners, today we want to present to you the results of our articles on the topic Computer Addiction as a New Way of Personal Self-Realization of Student Youth. The aim of our article is to analyze the manifestations of computer addiction as a new way of personal self-realization, to to empirically investigate the relationship of individual psychological factors of personal self-realization by parameters: motivation to succeed, relational self-regulation, development of emotional intelligence with subjective assessment of computer addiction by the student youth. Method. Based on the principles of a systematic approach, computer addiction as an integral part of self-realization of student youth in cyberspace was considered as a social psychological phenomenon that has many psychological correlates. Its development is ensured by the interaction of emotional, relational, intellectual components of young people's mental activity, which will promote dynamic cooperation of young people with diverse interests and provide new opportunities for activity and self-realization. Firstly, we should speak about the results of Young's test. It shows us that respondents in our sample had a slight degree of internet addiction. That is, they are able to control their actions, can correct them in time, or even cancel. They have a sense of control and predictability of their own actions. At the same time, using the internet brings them positive emotional arousal, which causes a slight degree of dependence. The next, we should speak about psychodiagnostic techniques for studying psychological correlates of computer addiction. The first technique is Shostrom's questionnaire, in which we showed that the vast majority of respondents have a high need for self-realization, and the remaining 36% an average. Such results are obvious in view of the socioeconomic demands that shape the labor market. The second technique is the Hall's test, that shows that young students are confident in their own awareness of themselves and others, but not motivated enough to achieve their own goals. To confirm this assumption, methods of diagnosing achievement motivation and violational self-regulation are used. The third technique is the questionnaire by Eller, that showed that a significant proportion of respondents have a moderately high level of motivation to succeed, and 32% medium. Developed motivation to succeed in student youth helps to increase the focus on results in current activities and will affect other basic competencies that help solve life problems: initiative, communication, ability to influence others, organization, responsibility, rationality. And the last but not least is the questionnaire by Zverkov and Eidman, that showed a high level of persistence. It is known that persistence is considered by many scholars as a predictor of success in various activities, including educational and professional. That is, such students are characterized by a more active, independent position and less likely to pay attention to difficulties. At the table of the slide, you can see a significant correlations between individual psychological factors of self-regulation of the personality, such as general violation self-regulation, persistence, self-control, and emotional control, and the subjective assessment of computer addiction of student youth by different parameters like an correlation coefficient, significance level, and sample. At the conclusions, we should say that an indirect connection has been established between the need for self-realization and computer dependence through correlation with general violation of self-regulation, self-control, emotion management. A direct positive relationship between the degree of internet dependence and the level of self-realization. Inversely proportional relationship between internet addiction and the ability to control emotions, and general violation of self-regulation. Thank you for your attention, and if you have any question, we will be happy to answer on them. Have a nice day. See you.
Thank you. Questions, please. No questions? Okay. Questions, please write in text chat. And we go next report. Professional competencies of future software engineers in the software design teaching technicals. Authors Stryuk and Semirikov, Kryvyi Rih National University, Kryvyi Rih State Pedagogical University, Institute for Digitalization of Education of the National Academy Education Studies of Ukraine. Speaker Andrei Stryuk. Andrei, thank you.
Dear colleagues, in our research, we pay detailed attention to various components of the professional competence of future software engineers. And the next stage is to study the problem of the forming competence in software design. Let me present the result of this study. A review of software engineering educational programs available at Ukrainian higher educational institution websites shows that software design training is accomplished in three main ways. Artificial introduction of design elements in different courses in close connection with the tools by the example of solving typical simplified problems on a certain industry. Spontaneous teaching of design elements during the internship on real tasks. Training on software modeling tool, usually UML. Only a small number of educational programs have attempted to take into account the global experience to design training organization based on synergetic combination of academic and industrial forms and methods of training. For some, the purpose of our study is to provide a historical and generic review to software design training practice of future software engineers. Modeling and analysis can be considered the basic concepts of any engineering discipline, and they are important for documenting and evaluating design solutions and alternatives. Chen Jihu puts a number of questions about what software design is. Can software design be defined using an engineering metaphor? For instance, design of a bridge must comply with appropriate laws of physics, but designing software has no laws of any kind to abide by, at least in theory. The most serious difference is that once construction commences, changes to the specification of an engineering product may not be allowed whether changes to software requirements are generally expected and can indeed happen anytime during the software life cycle. Can a computer program itself be considered a piece of art? It probably can, but not always against the same set of criteria. Can software design be defined by design activities? In fact, design activities are diverse. Many are certainly technical, yet some can be social too, but none is likely to be standardized to characterize design of its process. Can software design be defined by design artifacts to be produced or design phases to go across? The way to describe a design and document information, content and organization can range from the more traditional big design upfront all the way to the code is my design. In fact, a Gale practitioners believe that design is not only highly iterative, but emergent, and models often lie. Thus, only coding, running tests, and refactoring the code reveal the truth about a design. As a result, Childhood defines software design as a systematic, intelligent process in which designers generate, evaluate, and specify concepts for a software system whose structure and function achieves clients' objectives and user needs, while satisfied a specified set of constraints. The design process is both extremely creative and extremely complex, so it is not surprising that there are few truly understanding designers. However, the demand for new projects is very high. And to face it, each architectural and engineering industry has developed a set of principles that enable designs with average abilities to create design solutions of acceptable quality. Although software engineering is much younger than other engineering fields, it has also accumulated some knowledge of how to create projects, and future software engineers need to master this knowledge. So design teaching should be an integral part of their training. David Weiss presents experience of design software teaching invariant to the applied design methodology. His approach involves two stages. First, students are introduced to the principles underlying the methodology and the experience of applying these principles to small, well-defined tasks. In the second stage, students are offered a real task that they must solve independently and in a simulated work environment, receiving guidance on the methodological issues. David Weiss provides the following recommendation for the organization of software design training. Students must be advised by a design specialist who can ensure strict adherence to the methodology. The design task must be quite complex, and students are not allowed to simplify it. Students should be encouraged to make their own project discussions. None of the teachers should interfere in the discussion-making process. The size of the students group should be small to allow teachers to closely monitor the progress of each student. Computing Curricula 2020 defines the following competencies related to software design. Present business discussion methods, architecturally significant requirements from a software requirement specification document. Evaluate and compare trade-offs from alternative design possibilities for satisfying functionally and non-functionally requirements. And write a brief proposal summarizing key conclusions for a client. Produce a high-level design of specific subsystems that is presentable to a non-computer computing audience by considered architecture and design patterns. Produce detailed designs for a client for specific subsystem high-level designs by using design principles and cross-cutting aspects to satisfy functionally and non-functional requirements. Evaluate software testing consideration of quality attributes in the design of subsystems and modules for the developer. Create software design documents that communicate effectively to software design clients such as analysts, implementers, test planners, or maintainers. The core of knowledge about software design, Hu proposed to divide in two categories: design process knowledge and knowledge of design enabling techniques. The latter includes design patterns. Yancy Yam and Yongeltao considered modeling to be a central component of the quality software development process. The authors identify the following key concepts: modeling, the process of certain an abstract graphical or mathematical description of the design problem, during which the developer replaces a complex and detailed real situation with an understandable model that reflects the essence of the problem. The evaluation of the model in the iterative process of development tends to preserve the form of representation, while the transformation of the model involves a change in the point of view from which the design problem is considered, and a change in the structure of the design model. Code refactoring is the process of changing the code of a computer program in order to preserve its ability to develop, improve its reliability, or simplify the structure, while maintaining existing functionality. Refactoring training not only gives students practical programming skills, but also helps them understand the most important principles of software engineering. Design patterns can help developers solve certain design problems, as well as improve existing projects. Design pattern provides a conceptual model of the best practice solution, which in turn is used by developers to create a concrete implementation of their task. The use of design patterns has a number of advantages. The pattern provides a guide to best practice. The use of the pattern provides developers with a common dictionary for easy and clear discussion of complex design concepts. Due to this and other advantages, design patterns are often studied in software design courses. Chad Williams and Stan Kurkovsky amplifies that the process of learning to the appropriate software design patterns can be made creative by transforming the design process itself into a constructivist learning environment. To do this, they propose not to limit the subject of student projects and creative conditions for students to get out to get out of the comfort zone by applying new hardware platforms and interface to them. The interim evaluation of the project was performed according to the level of expediency and the number of used design patterns, and the final according to the level of creativity of the whole project. The authors propose a three-step process of learning design. First, students are asked to design their program using object-oriented design. Using the formulation of the problem, students are encouraged to object-oriented thinking and use a previous experience to create objects, classes, responsibilities, relationship, methods, and other UML entitlements. Next, students are asked to rewrite the program using design patterns. One of the patterns is the model view controller pattern. Finally, students are asked to adjust the use of the design pattern according to the chosen framework. Idea at all offer a methodology that will give students the opportunity to take advantage of the framework into implementation of their project. Paraphrase the problem statement and extract all the nouns and verbs from it. The nouns serve as candidate objects, classes, and attributes, while verbs serve as responsibilities. Merge the extracted nouns into classes. This may require discarding irreal nouns or nouns representing the same thing. Merge extracted verbs into classes instead and responsibilities. Assign responsibilities are in defining required methods to complete those responsibilities. Walk through the scenario to ensure that each scenario is supported by methods and identify the collaboration between them. Design is an inherently and interdisciplinary subject, influenced by a larger number of human factors. So teaching design is not only a process of teaching design itself, but also a process of future developing students' social skills. Stanislav Yazabek notes that team-oriented project courses provide an opportunity to learn the principles of software engineering when their application is really necessary and profitability, and suggests the following classification. Industrial attachment, in which students work on real-world problems in industrial settings. Project course is which students work on problems in various application domains under supervision of faculty members, experts in a given domain. Sometimes such courses build on real-world problems provided by industry. Project courses in which students learn advanced software design principles and apply them in their projects. As faculty members need to scrutinize and detail design artifacts to provide feedback to students. Such projects might be supervised by faculty members specializing in software engineering and well versed with problem and solution domains students work with. Projects developed from scratch versus projects in which students extend existing software. Projects based on the specific software platform, such as .NET service, mobile device, or Facebook. Murtagh and Hamilton Jr. describe the organization of project-oriented learning, determining the following desired learning outcomes of students. Students should use the knowledge of previous computer science courses to develop moderately complex computer projects based on clear, consistent, and reasonably complete requirements presented by the teacher in the project task. Students must develop high-level architectural projects of programs and their interfaces and obtain the approval of the teacher before moving on to detailed design. Students must demonstrate that all requirements for the project assessment have been allocated to specific parts of the architectural design. Students must develop a detailed non-architectural project of software and all interfaces and obtain the approval of the teacher before embarking on implementation. Students should develop a test plan for each project. The test plan should demonstrate how all software requirements will be tested and include a software testing schedule. Students should develop documentation that show how their software and test plan meet the requirements of standards. Jan Warren methodically substantiated the learning outcomes of software design training. Identify and describe the objectives of software design. Design objectives include the correctness, robustness, flexibility, reusability, and efficiency. Students should appreciate that software should not only be correct, but that the latter for non-functional objectives are also important. Interpret and construct UML models of software. The UML, being the standard industry notation, is an obvious choice for communicating design knowledge. Essentially, students should be able to read and write UML models. Explain the notion of design patterns and describe a subject of patterns. Design patterns embody prone design solutions. Students should appreciate that using pattern fosters an engineering approach as opposed to one that solves problems from first principles. Apply patterns to solve real-world problems, making systems trade-off when necessary. Awareness of patterns is important, but is not obtained for being able to apply a pattern to solve a problem. This objective is considered with deeper functioning knowledge. Apply newly acquired and developed programming skills. Students have functioning knowledge of fundamental OOP, but have limited knowledge of Java class libraries and more advanced aspects of programming. These objectives aims to equip students with stronger implementation skills. Work with reality large software projects. Similarly, students' experience of development software is typically confined to small programs involving a few classes. Exposing students to larger projects is good preparation for final year project work and industrial practice. John Whittle and others offer another alternative to traditional learning, studio-based education, which brings to the forefront reflective practice as a way to develop design skills. In the studio, students are invited to critically reflect on their own and others' design, using a variety of techniques such as mentoring, design criticism, material mentoring, and considered evaluation. Software design experts, for example, Martin Petrie and Andrew van der Hoek, used informal modeling to summarize their own design experience. The combination of informal and formal modeling is possible with the help of flexible modeling tools. which after creating an informal sketch provide an opportunity to move to formal modeling without changing the tool. Petter and Hook recommended the following action for reflection in software design. Do not allow deviation to minor issues when discussing the project. Regularly check yourself. When am I and what I am doing? Based on the deep understanding and the fundamental concepts of design, keep up to date. Remember what design discussions have already been made, why then were so, and what other discussion need to be made. Thinking about what is not designed, identifying and considering design limitation, to identify the design exceptionally or inefficiency. Periodically stop to look at the project as a whole, asking yourself whether the goals of customers, user perceptions, the market itself, etc., have changed. Anticipate different options for the future, analyzing the economic feasibility of determined where to invest in methods, tools, resources, design alternatives in order to save efforts in the future. In a study of design, Cheney Hu recommends to consider the following. Students' technical competency and cognitive strength can significantly impact the outcomes of learning design. For relative small-scale design problems, test-driven development renders opportunities to express modeling ideals directly in code, allowing more effective evaluating to design trade-offs and committing less design errors than using diagrams. Learning small-scale design, writing related methods, appropriate data encapsulation, using good methods names, etc., is probably much less challenging than studying design in general to study structural stability, which requires design compromises and applying knowledge to the design process. The minimum basic design skills with an appropriate level of project thinking that graduates must acquire may include the ability to effectively begin design, decompose a task, perform design iterations with sound design compromises solutions, and implement the project in code. Students cannot effectively acquire the ability to design and learn project thinking if they do not solve design problems of appropriate complexity. Despite the lack of universal formulas or design recipes, data analysis, identification of entities and their relationships, and process analysis, detection of action and logical flows, is critical to understanding what information to use and how it is transformed. Correctly documenting a design, timely, not post factum, is a necessary skill. However, whether students should use UML or how correctly they use the language to document the model is not so important. It is advisable to acquaint students with some classical diagrams, encourage their creative use. For the final assessment of students' learning outcomes, it is advisable to combine traditional classroom tests to make sure they know this with complex design homeworks, which must be solved individually or in teams or two with careful monitoring and evaluation of finished design products made by students, but also the quality of project implementation documented in student report. Summarizing the results of the study has provided an opportunity to draw the following conclusions. Software design is a type of engineering design which combines two components, creative and systematic technical. In teaching software design, special attention should be paid to supporting students in design, the theoretical foundation of which are acquired in the form of lectures, in the form of practical classes, studies, courses, projects, etc., to solve real problems of complex software design. Software modeling plays a key role in this successful design. At the same time, compliance with the requirements for the use of accurate formal description of model in the design process does not significantly affect the quality of design. The transition from architectural design based on the chosen pattern to non-architectural detailed design may require adapting the pattern to non-design realities in the form of software design tools, such as the framework. Assessment of the formation of the competency in software design involves testing individual knowledge and team skills of design in the process of solving a complex design problem. Design artifacts such as sketch designs, formal models, design documentation, prototypes, and more are important for this. Therefore, the difference of projects is an appropriate form of evaluation. Prospects for future development of this study are too substantiated the third, after requirements engineering and design engineering, engineering component of software engineering, software construction. Thank you for your attention. I will be happy to answer your questions.
Thank you. Thank you. I hope there are no questions. Please write questions in the chat and we move on to the next report. Next report, motivational readiness of future teachers, philologists to use the gamification with elements of augmented reality in education. Authors: Petrovich, Zavalnyuk, Bogatka, Polarush from Vinnytsia Mikhailo Kotyubinsky State Pedagogical University. Okay.
Good day. I'm Gabriel Plata here to present our study for the application.
I'm sorry, one moment. It's my...
Okay. We wait.
Что пошло не так?
Это вообще не из этой секции.
Вот,
Сейчас должна быть Ольга Петрович, это из РЭДУ списочек. Ты его.
Please, microphone off. Andrei and Sergey.
Sorry.
Dear colleagues,
Let me present the
and demo presentation on our screen. We don't see. Okay, yes. Start, please.
Dear colleagues, let me present the topic of our research, motivational readiness of future teachers philologists to use the gamification with elements of augmented reality in education. Technologies of gamification and R are among the trends of modern education. These innovative tools are aimed at modernization of education, forming the modern system of its organization, taking into account the digitalization of education. The experience of researchers has shown that gamification and R in learning are the advanced technologies that increase the effectiveness of education, because there is a need to capture the students' philologists' attention and inspire them to work from the first minute of the lecture and workshop. The use of gamification in the educational practice of higher educational institution allows to solve a number of problems related to the use of R, the implementation of the principles of difficulties, and accessibility of learning. Individual approach, optimization of the educational process, and to increase the level of interest in studying discipline, form the ability to work in a team, etc. The aim of the research is to find out the motivational potential of students philologists to implement gamification with elements of R in the system of language and literature education. Various aspects of the problem of implementation of a gamification in various spheres of human life, including education, are researched by Sebastian de Teding, Robert Songer, Kazunori Mayata, Zachary Fitz-Walter, Anna Manzano-Lyon, Dimitrios Karagiegos, and Sharon Newman. The use of R games for educational purposes is researched by Sylvia Barma, Henry Sobermanos, Sylvia Balduris, and Raman Fabregat, Jahi Lee, Guo Yen Won, and others. The annual international workshop REDU, which has been since 2018, strengthens the contribution of domestic and foreign scientists in the development of augmented and virtual reality in education. Thus, according to the analysis of scientific papers, the use of R gamification has significant potential for the effective organization of the educational process of future teachers philologists. Despite the interest of scientists in R gamification, its role in formation the readiness of future teachers of Ukrainian language and literature for professional activity requires further researches. Implementation of gamification with elements of R into the educational process of Mikhailo Stelmach Faculty of Philology and Journalism in Vinnytsia Mikhailo Kotyubinsky State Pedagogical University aims to form professional competencies in future teachers of Ukrainian language and literature, namely pedagogical competence, critical thinking competence, competence of creative literacy, and disclosure of persons' potential opportunities, motivation of students' active involvement in educational process, their information and digital competence. We briefly describe the algorithm of creating a board game. First of all, to define the theme and aim of the game. Students philologists have chosen to create a game to section folk and literary tales, which is studied on the lessons of Ukrainian literature in 5th grade. The second step is to identify the subject of learning, for example, age and number of players. The third step is to create the game mechanism, game mechanism was based on Bloom's taxonomy, so task cards were developed according to the following levels of cognitive activity: knowledge, comprehension, application, analysis, evaluation, creation, and one more group of cards was also created as bonus. The first steps is to make the rules of the game. Student philologists indicated in the rules the duration of the game, age of players, for example, 10, 11 years old pupils, number of teams from 2 to 6, number of team members from 3 to 6, game props, goals, algorithm of players' actions, conditions of the game completion. And in each category of this game, there are 6 one-level tasks. Cards with the Imagine, as in Figure 1, denote encrypted information in the form of R. A player needs to use the Unite R mobile application to read it. Here are some examples of the game cards with R, which involved students to trace interdisciplinary links with foreign language and literature, to watch a video in TikTok about the fairy tale egg right there and determine which of the animals depicted there wasn't the hero of this tale, to watch the video and find a logical connection between the citation material and find a superfluous imagine among the illustration and explain their choice, to recognize the illustration to the fairy tale and to match it with a quote from the correlating tale. Thus, the creation of board games with elements of R by the joint efforts of the future students philologists became a kind of success situation. This has led to our interest in researching the motivation of future teachers philologists in the use of gamification with elements of R. Methodics for diagnosing the motivation of future teachers of Ukrainian language and literature to the implementation of gamification with elements of R in educational process is based on the methodics motivation of studying in higher education by Tatiana Ilina. We determine reproductive, productive and modeling, creative and innovative levels of formation and of motivational readiness of future teachers philologists to use gamification with elements of R. 47 students of the fifth year study of Mikhailo Stelmach Faculty of Philology and Journalism of Vinnytsia Mikhailo Kotyubinsky State Pedagogical University took part in the survey. The experimental group included 21 students and a control group 26. Both groups learned the theoretical information on gamification and R, but only the experimental group was involved in creating a board game with elements of R. So only this group worked on a creative, practice-oriented project with the usage of these technologies. Generated data of the levels of formation of future teachers philologists motivational readiness or to the use of gamification with elements of R is given in percent in figure 2. Comparing the indicators of the levels of forming the students' philologist motivational readiness to the specified activity, we trace their tendency to a better formed level of motivation among students of experimental group. It should be noted that the reproductive level of students' philologist motivation to the use of gamification and art technologies is due to the fact that those students of experimental and control groups, which according to the survey are at this level, they work in parallel with studying and have absence on the lessons where these technologies were considered. They were also passive in acquiring basic knowledge and skills in using these technologies. In addition, it occurs that the significant difference between the indicators of creative and innovative level of experimental and control groups is due to the methods and techniques used on the classes for studying the peculiarities of gamification and art technologies. We consider that the use of gamification with elements of R allows to form a student philologist's strategic vision, creativity, independence, and determination in decision-making, to activate the future teacher's philologist communication skills and ability to teamwork, to promote the formation of skills of tact search and processing of information, to increase the level of students' philologist motivation to study disciplines, gaining the ability to use knowledge in practice, including in organizing and conducting effective lessons and extracurricular activities in Ukrainian language and literature. Achieving such a result is possible due to a pedagogically appropriate combination of educational methods and technologies and their close interconnection and integration, for example, gamification, augmented reality, project activities, and practice-oriented activities. A prospect area for further research is the study of the effectiveness of using the created board game Imaginarium during the pedagogical practice in secondary schools. Thank you for your attention.
Thank you. I see questions in text chat. A good option if the participants write questions in a text chat while the presentation is in progress. And presenters will be able to answer there or after the presentation by voice. Voice or text chat, answer for questions?
Thank you. I already answered in the chat, and I can repeat it in voice as you say.
Okay. Any questions? No. That's good. Next presentation and next report, using online services to create comics with elements of additional reality in the educational process of elementary school. After Bodnenko, Lokazyuk, Poryadchenko, Proshkin from Boris Grinченко, Kyiv University. Please start
Dear
video
colleagues,
presentation.
dear organizers, thank you for organizing a wonderful workshop. Present to your discretion our study on the topic using online services to create comics with elements of AR in the educational process of elementary school. Authors of the study are Svetlana Litvinova from the affiliation to Institute of Information Technologies and Learning Tools of NAIS of Ukraine, and others from the affiliation to Boris Grinченко Kyiv University. Our report plan consists of analysis of cloud services for creating comics, algorithm of development of educational materials in cloud services for the creation of comics, determination of the real state of readiness of teachers and pupils to use cloud services to create comics with AR elements, authors, educational and methodological support for teachers. There are plenty of online services and apps to create comics. However, not all of them are suitable for the teachers to organize work in class. Lack of time for training is also a problem, because the service must not only be found, but also learn to work in it and know how and when to use the developed materials. In the study, we were interested in functional, free, and most importantly, simple services that provide easy access to programs for both teachers and students. Each of these online services contains a certain number of templates grouped by types: people, children, teens, young men, adults, elderly people, animals, things, transport, special characters, backgrounds, school, forest, city, houses, historical and mythological use, nature, etc. When creating a plot, you can choose the expression of the face, the position of the body, the mood of the hero, change his appearance, pose, and others. The advantages of using these services are availability of services in material terms. Most are free or have the possibility of using the trial-free version. Simple interface. Use of templates. Each service has its template database for use. The ability to create a completely new product. The ability to download all resources is provided. Dissemination of materials. It is possible to disseminate or the created materials of the author. Versatility. Materials can be used to work in any lesson for individual or frontal work, both online and printouts. It is also worth highlighting the disadvantages. Other language interface. Most programs are foreign, but there is a possibility of using Google Instant Translation. Preliminary training of teachers and students. Conversion. Not all files format are supported. Their size is limited. The creation of training materials such as comics using the specified software can be supplemented with AR elements. The experience of implementing the educational process using AR also allows us to highlight programs for developing and working with AR. Vuforia can easily create marker-based AR, markerless-based AR, and cloud-based AR. Easy AR offers its next-generation SDK, which has some features such as SLAM, 2D and 3D screen tracking and recording, cloud-based object recognition, and unlimited recognition requests. MaxTed offers two types of augmented reality software, MaxTed AR SDK 2D and MaxTed AR SDK 3D. AR Core is not only supported on Android but also on iOS devices, allowing you to develop cross-platform AR applications. AR.js is an open-source AR SDK based on JavaScript, can create AR stands based on markers. 8-Wall provides support for markets, image target, world effects, face effects, and SLAM. Algorithms of development of educational materials in cloud services for the creation of comics. For example, we present Pixton, Write Comics, and Comica. Those are comics designers that basically allowing you to create your stories almost from scratch. It includes customizing everything, background images, people postures, emotions, image details, and etc. As a result of the experiment, we found the willingness of teachers and students to use cloud services to create and use comics in educational practice. Via appropriate criteria and levels of readiness have been identified and developed. You can see a slide. As a result of the questionnaires developed by us on the theoretical principles of using cloud services, tasks on working with cloud services, and the result of self-assessment, the real state of readiness of teachers and students to use cloud services for creating comics with AR elements was revealed. According to the results of the study, students and teachers showed approximately the same ability to use cloud services. Most students, 63% of the total number of respondents, and teachers, almost 68%, have an elementary level of readiness. Only 10 and 7% of students and 8% of teachers reach the creative level. To compare the results obtained, we use the Pearson criterion. You can see it at the slide. The obtained data indicate an overall trend regarding the research problem and require finding ways to improve it. On the next presented slides, we presented the main conclusion of our study. Thank you for your attention.
Thank you. Questions, please? No questions. In text chat, no questions too. Why? very interesting presence, and we write questions in text chat, and we go to next presentation, next report, the mobile AR application for advertising faculty educational service after Marchuk, Levkivsky, Graf, Dombrovskaya, and Panarina from Zhytomyr Polytechnical State University. Please play presentation.
Good day, dear colleagues. I want to present our work on the topic mobile AR application for advertising faculty educational services. The purpose of this study is to design and develop a mobile application of advertising educational services of the Faculty of Information and Computer Technology, Zhytomyr Polytechnic State University in Ukraine, with using augmented reality technologies. The application provided visualization of a university building as well as the environment in the form of 3D models and animation of some object. Cards with brief information about each specialty of faculty and links to useful resources will also be created. Interesting to use this technology for advertising purpose of the educational opportunities. Advertising goes beyond gadgets, postcards, and other familiar frames. Using the offered software product, you can learn about the educational proposal of the Faculty of Information and Computer Technology of Zhytomyr Polytechnic State University. For creating a project, we used a program Blender. This program allows creating detailed models for the project base of photographs, and also combination of programs Unity plus Vuforia for creating an augmented reality application for the user and adding information. The main advantage of using a Blender, it has a large number of components. It can be used to create three-dimensional models of arbitrary complexity. You can create simple 3D models without programming skills or complex with programming and design rules. Unity, it is very effective while rendering 2D and 3D scenes. In this era of visual threads, Unity can very well be used for rendering 3D images also. The quality of it is also relatively good compared to other apps. Unity is excellent for cross-platform development and multi-platform games. The key advantage of Vuforia is that it can be used for iOS, Windows, and Android devices. Moreover, the SDK is easily integrated for all the devices and not limited to the latest processors and defined by ARKit SDK. The specificity of augmented reality technologies is a visual combination of a world of real objects around us with the world of virtual objects created by human. This is created by overlaying the created 3D objects on top of the video signal from the camera. The basis of augmented reality technology is an optical tracking system. This means that the eyes of the system become of the camera and the hands the markers. The camera recognizes markers in the real world, transfers them to the virtual environment, improves one layer of realism and on another, and thus creates a world of augmented reality. This slide shows the marker technology of Vuforia. Marker technology uses static markers of activate 3D objects. Throws the camera, the program recognizes the marker or object in front of it and then displays the created 3D models on top of the marker or object. Markers can be QR codes, generated points of the images, brand logos, etc. All interactivity and gameplay in Unity is built around three fundamental building blocks: game objects, components, and variable. Any object in the game is a game object, be it characters, slides, special effects, scenery, and everything else. Components define the behavior of the game's objects they are attached to and control them. The diagram you see show the game objects in the create application and the constituent components. A state diagram is used to describe the behavior of the application. The slide shows a diagram of the transitions between two states of a mobile application. This is a graphical representation of a state machine for software and systems, show a behavioral model consisting of state transitions and actions. Represented the permitted state and transitions as well as the event that affect these transitions. Several graphics have been developed to create the augmented reality mobile application. All three-dimensional models were developed in Blender. The main models created in the university building. The initial appearance of this model is shown of the figure on the left. Add texture to make it more realistic. The result of adding texture is shown in the figure on the right of the slide. Thus, the main model of appearance of the Zhytomyr Polytechnic State University was obtained. In addition to the main object, a number of other have been created. Models of three whose leaves should have animation movement in the field. Models of people that can be seen in the middle of the slide. Each human object has an animation of walking on its own trajectory. The interface of the application is quite simple. Management is carried out by means of a smartphone camera and pictures of triggers. The image of a program after clicking on the start button can be seen in the figure on the slide. After launching the mobile application and pressing the start button, calm music starts playing and the animation of a university appearance will start. Near the university, there are people who have an animation of walking, trees whose leaves have an animation of wrestling, as well as benches, lanterns, fountains, and inscriptions above his head. Another button menu appears on the screen. The result of pressing a button, you can view a model of a university by tuning around a paper advertising. It is also possible to enlarge or reduce the image of institutions. Also possible to open the Google Maps service, which will indicate the location of the Zhytomyr Polytechnic State University. By pressing the I button, the user will open several cards. All cards have the same design. They are depicted in the form of a rectangle with round edges. Each of them is a representation of a separate specialty at a faculty. At the top of the card, you can see the name and number of a specialty. Below is a list of preferences, subject, or interests about each specialty. At the bottom of the card, the user sees a button labeled View Animation. When pressed, instead of the card appears Sprite Animation Related. By flipping the screen on the left, the user can see all the animations and all the cards. To close the card view, the user must click on the eye icon again. The main conclusions are given on the slide. The paper proposed to use one of modern technologies of extended reality to increase the interest of applications. Created the models, animation, applications in augmented reality. Also based on the result of this work, it was proposed to create a new selective discipline in the educational process, RVR programming. As a result of using the developed mobile application, the number of applications from entered to faculty was increased. Statistical indicators of growth of entrance in the specialty of the Faculty of Software Engineering, Computer Science, Information Systems and Technology for the last 3 years is the amount of 40%. In the future, it is planned to expand the mobile application, the possible use of other extended reality technology, adding discipline and competence list of proposal for specialties in the labor market application at other faculties of the university. Thank you for attention. I am ready to answer your question.
Thank you. I see a new question in text chat from Irina Krasheninnik. Do you have any data about using this application by applicants or students? Were they interested? Was this application helpful for you, faculty?
Thank you for your questions. As a result of using the developed mobile application, the number of applications from entrant to the faculty was increased. And for the last 3 years, we see in the amount of 40%. And also, based off the result of this work, it was proposed to create a new discipline in computer science. Name of discipline augmented reality, virtual reality programming.
Okay.
Students are more motivated to learn when they see the result with their own eyes. This is the opportunity provided by augmented reality.
That's all?
Yes, thank you.
Okay, thank you. Any questions? No, good. Next topic and last topic today, experimental verification of augmented reality technologies usage for teaching global reading to preschoolers with autism spectrum disorders. Authors Kolomoits, Belikova from Kryvyi State Pedagogical University. Please play video presentation.
I'm sorry, we have not a video presentation.
After spin online?
We hope the author.
No. Very bad. Very bad. By today, very good day. We walk and done a lot very big interesting topics, and from Andrei technical supports say about today sections, and Andrei, please.
Well, thank you for your participation. And I invite, now we have a coffee break, and I invite to the next part of this conference at 2 o'clock on the Kyiv, after 1 hour.
The same link, but another faces.
Yeah.
Okay. Okay, thank you. Today we had a lot of reports. I'm very grateful to everyone for their active participants. Glad. See you again. Don?
Yeah.
Goodbye.